Okay, so this video is here to help you understand a velocity graph, how to read it, and how to use it to answer a bunch of questions. Some of the main vocabulary words that you need to be responsible for out of this is over here in orange. So like understanding what velocity is, and that's defined right over here. How fast that the position is changing. And notice that this is a velocity graph, so we're just going to use the graph to get that information. What speed is, what acceleration is, and what displacement is. So we're going to start with the first couple of vocab words throughout these questions here, basically 1 through 8. So let's take a look. So again, this is a velocity graph. It's in time and seconds, so about 0 to 13 seconds here. And the y-axis represents the velocity in feet per second. Remember, velocity can be positive or negative, whereas speed is right here is the absolute value of velocity, or you could just remember it as the magnitude of velocity, because velocity has a magnitude and a direction. So when the velocity is positive, you're moving forward. When the velocity is negative, you're moving backwards. But the speed happens to be like the absolute value of that number. So if the velocity is -1, the speed is really just 1. If the velocity is -2, you're moving backwards, but the speed is 2. So if we read the graph, right at time 0, the object is stopped because the velocity right here is 0. By the time we get to 1, the velocity is 1. And so on. As we get to like 3 seconds, the velocity is 3. At 4, the velocity is still 3. It's a constant velocity, so it's not stopped right here. Right here, the velocity would be called constant. You're always going 3 feet per second, so you're still moving forward. In fact, you're moving forward this whole way, here, and even here. So from 0 to 9, the object is moving forward because all of the velocities are all positive here. So right at 9 seconds, the object is stopped. And then from 9 through 13, the object is moving backwards here because all of these velocities are negative. Again, their speeds are positive. The speed is always positive, except for when it's 0. So let's just look at the vocab here, get familiar. Positive velocity means you're moving forward. Negative velocity, you're moving backwards. 0 velocity, you're stopped. So for question number 2, you're moving forward right here, 0 through 9, because the velocities are all positive. Question number 3, you're moving backwards from 9 seconds to 13 seconds because all of the velocities are negative right here. And you're stopped right here at 0 and at 9 and then at 13 because all of these velocities are equal to 0. And then number 5, changing direction means you're going forward and then going backwards or vice versa. So that happens right here at 9 because you're moving forward and then right at 9 you stop and then go backwards. So 9 is called a change in direction. Okay, so speed right here, number 6. Again, you find that by getting the absolute value of velocity. We're just putting these bars on top of velocity. Number 7, it says, what is the speed at 1 second? So right here at 1, you just go up to the graph and read that. So it would be 1 feet per second. 4, just go read the graph. The speed and the velocity are both 3. So that's 3 feet per second. At time 10, you go down. You just get the y value right here. The velocity is -1, but the speed is 1, so that's why we just have a positive 1 right here. And then again at 12, speed right here is a positive 1. For questions 8, at what time is the speed increasing? Well, you just need to look at the red numbers here. The speed is 0, then 1, then 2, then 3, so the speeds are going up here. They're constant here, so that's why the first answers is 0 through 3. The tricky part is right here, 9 through 11. So at 9 seconds, the speed is 0. At 10 seconds, the speed is 1. At 11 seconds, the speed is 2. So this interval right here, 9 through 11, the speed is increasing because it was at 0, then 1, then 2. So the speed is increasing right here. But you can see this part The 11 through 13, the speeds are decreasing because the speed is 2, then 1, then 0. So if you want to put numbers for yourself next to those, you could just read left to right, 2, 1, 0, the speeds are going down. And the same thing happens 7 through 9. So at 7, the speed is 3. And then at 8, and then at 9, the speeds are going down. So we have decreasing speed. Okay, so that brings us to our next concept, which is acceleration. So just to remind you, acceleration means it's the change in the velocity, and the unit for that would be feet per second per second. And if you look at this little T-chart, this might help you understand that a bit more. So at time 0, the velocity is 0. At time 1, the velocity is 1, and so on. Just did the first 4 seconds. So you can see for the first 3, this is the graph that we're looking at. Just this part, the first 3 seconds. You want to know how fast is the velocity changing. So since the velocity is changing up 1 feet per second every second, that would be your answer. Like the acceleration anywhere on the first 3 seconds happens to be 1 feet per second, which just happens to be the slope. So you could get that like a rise 3, run 3, or we'll put it right here, rise 3, and that's feet per second. We just went up 3 feet per second, and then we're going to run 3. We went over 3 seconds, and so this just reduces down to 1, which is our slope, and then the unit, feet per second, or you could call feet per second squared, is the acceleration unit right here. So acceleration, again, means how fast the velocity is changing, and you get that on the graph just by finding the slope. So that's what we have. These questions right here. How is acceleration found? Just right here, slope of velocity graph. When you have positive acceleration, you essentially just have positive slope. When you have negative acceleration, you have a negative slope versus a positive slope here. Constant acceleration. So that would be like 3 to 4 seconds. If the speed is 3 or velocity is 3 and then it remains 3, you had no change in the velocity. That's why the velocity right here from 3 to 7 would be constant. So the velocity is a constant 3, meaning that your slope would be 0, meaning that your velocity just is not changing. So you just figure out the slope, and that will be your acceleration unit. So anywhere in between 7 and 9, this slope here would be negative. So you know your velocity is decreasing. You have a negative acceleration going on right here. And to figure that out, you just have to get the slope. Anywhere between 7 and 9 seconds, looks like you go down 1, 2, 3, and then over 2. So negative 3 halves feet per second would be the acceleration for anywhere in between 7 and 9 seconds. If we did something between 11 and 13, so this right here, we're below the x-axis, so the velocities are negative, but the slope is positive. So your acceleration here would be like up 2 over 2, or just 1, and that'd be feet per second squared. This here would be a negative 1 feet per second squared. Okay, the final topic for a velocity graph is to understand what displacement is. So a reminder, the displacement means the change in the position from like a time 1 to a time 2, or time A to time B. And the unit is usually going to be feet, but let me show you kind of how the unit gets created. In acceleration, you use the slope, or delta y delta x, and the delta y unit is feet per second, and the delta x unit, the x unit is seconds. So when you do slope for this, it'd be feet per second, or gives you feet per second squared. Well, displacement, to figure this out, is the area under the curve. So we could use this right here from 0 to 3 seconds for an example. So you go from the graph down to the x-axis, and you go get this area. And it's usually like rectangles or triangles. So as a general, like a rectangle would be length times width, or just the opposite of delta y times delta x. And so the delta y unit is feet per second, that's the velocity unit, times seconds, and the feet per second times seconds, the seconds would cancel out and give you a unit of just feet. And that's why we have feet right here for the unit for your displacement. So then to calculate how far the object traveled in the first 3 seconds, you go get the area of this triangle right here, which would be a 3 by 3, that's 9. So a triangle is half of that. So that's why this is 4.5 feet. And I put forward because our velocity is positive. One more example, 3 to 7 seconds. From here to here, it is just creating a rectangle. So this would be from 3 to 7. Our delta x is 1, 2, 3, 4. By our delta y, or 3. So 4 times 3 gives you, well, let's double check that. So from 3, we got 4, 5, 6, 7. Yeah, this should be 4 by 3. So this 15 is actually should be a 12. We went 12 feet forward right here. And then 9 to 13, we could double check this one. From 9 to 13, we have this whole triangle piece here. So from 9 to 13 is 4. So it's 4 across, and it's 2 down. So 1/2 times 4 times 2 equals 4, which is right here, 4 feet. And we put backwards because our velocities are all negative. So you can see the object is moving forward from the first 9 seconds, and then backwards from 9 to 13 seconds. So that's why backwards 4 feet. So this, if we look at question number 18, it says if the particle started at 10 feet at time 0, then what is the position at 13? Let me pause the video and just double check this. Okay, yep, so the mistake, I caught the mistake. Let's fix this down here. So this is saying that right here at the very beginning of the problem, the object just started at 10 feet. So that was just made up, that was just created. So in the first 3 seconds, it moved 4.5 feet. That's the area for this part right here. It then moved another 12 feet forward for the next, so from 3 to 7. Alright, so turns out there was not a mistake. What I did have a mistake on is I did not calculate the 7 to 9 in one of my original calculations. So just to clarify, sorry about this, we started at 10 feet. We went 4.5 feet forward here for the first 3 seconds. Then we went another 12 feet forward from 3 to 7 seconds. And we went another 3 feet forward. That's this area of the triangle from 7 through 9. So that's 3 by 2. Half that is 3. So this is all of the forward movement. 4.5 feet, 12 feet, 3 feet. And we went backwards 4 feet. That's the area of this from 9 to 13. We went 4 feet backwards. So we ended up at a position of 25.5 feet if the particle or whatever started at 10 feet from the beginning of the problem. Okay, we're going to do some more videos for some more examples.